Okay, let's see another example. We have, I will read it for you. Please try to understand this. Try to understand this. A dam is being considered on a river that periodically overflows. Each time the river overflows, it causes about $600,000 in damages. The project horizon is 40 years of this dam, which will be 40 years lifetime. A 10% interest is being used. 3 different designs are available, each with different cost and capacities. The Weather Service has provided a statistical analysis of annual rainfalls in the area draining into the river. Assume that the dam requires no annual maintenance, has zero salvage value at the end of 40 years life, and is empty at the start of each annual rainfall season. Which design alternatives to choose? We have 3 design alternatives. Design A, design B, design C. Their costs are given here and how much they can store. So design A can store 1 unit of capacity, and B can store 1.5 unit, and C can store 2 units. The unit can be acre feet, million acre feet, cubic feet, whatever the cubic meters, whatever it is used. We are not worried about that unit. We say 1 unit, 1.5 unit, 2 units. All right. Here we are given the probability of rainfall. There is 0 probability, zero rainfall, 0.1 probability, 0.1 to 0.5 we have 0.6 probability, between 0.6 to 1 we have 0.15 probability, etc. Now we are asked to find out which design is better, and remember that each time there is an overflow, $600,000 is a damage there. The project life will be 40 years, whether it is project A, B or C, design A, B or C, it will have 40 years of lifetime. And there is no zero, there is a 0 salvage value, no salvage value at the end of this lifetime. How to solve this problem? Again, we can solve it on the annual basis, or we can solve it on the total cost basis. Both ways are correct. As you can see over here, design A can hold 1 unit. So anything above 1 unit will overflow. And when there is an overflow, this is the damage. As you can see over here, we have probability of 0.85. There is no overflow for design A. 0.1, 0.6 and 0.15, the total is 0.85. Probability is that there will be no overflow. Only 15% chance is that there will be overflow if we go for design A. If we go for design B, it can hold 1.5 units. So for 1.5 units, the only overflow will be only from these two, 0.04 plus 0.01. So total is 0.05 probability of damage if we go for design B. And if we go for design C, it can hold 2 units, and it means that only we will have a probability of damages 0.01. Clear? Any questions? Now we can have expected damages, annual damages, and we can annualize this cost, and total annual expected cost of design A, total expected annual cost of design B, etc. We can do it on annual basis, or we can do it on total cost basis. Total cost of this is already there. What we have to do is we have to find out the damages, probability of damage multiplied by, you have to, because 40 years of lifetime is there, just multiply with present worth factor, and then you will have the total cost also. So both ways are correct. Let's try to solve this problem. You have any questions?
So what does probability means here? Does it mean that it is going to certainly happen or may happen? How do we calculate the damage cost?
All right. As you have a course on probability and statistics, I am sure that you know what is probability. Probability is the chance. It may happen or it may not happen. But the probability comes from long statistics. So they have a statistical analysis of annual rainfall for the last, maybe they have 30-40 years of data. They know that what is the probability of rainfall of this each year, and they have a probability of rainfall, and how much rainfall and how much is the probability. They have this data. So this data is given to us now. Probability is a chance. It can happen, it may not happen, but it is coming from statistics from long time of data.
So 0.1 means 10%, for example, is going to exceed between 1.1 and 1.5, and 90% is not going to be within that range.
Right, right.
So you may be required to pay that $600,000, or you may not even need to pay it for a specific year.
Yeah. If the overflow doesn't occur, then there is no damage. There is only, we can find out the expected value. When we have the probabilities, we work with expected value, not the actual. We don't know actually what will happen, but we can say expected damage because the probability is there, right? So expected damage from, let's say, design A, annual damage, expected annual damage from design B, and expected annual damage from design C. This is expected value. It may occur in 1 year, it may not occur in several years, and only occur in few years, but it is just an expected value. واضح? Okay. So let's try to solve this problem now. I suppose just remember these numbers. If you have the, you just have to tell me what these numbers are, and we are going to solve this. What was the discount rate? 10%. So in this case, we can work out the present worth factor also and capital recovery factor. Present worth factor is equal to 1 plus I raised to power n minus 1 divided by I into 1 plus I raised to power n. So we have, again please, it was 10% discount rate? So it was 1.1 raised to power 40 years lifetime minus 1 over 0.1 into 1.1 raised to power 40. And same way you can calculate the capital recovery factor. It is the inverse of present worth factor. Please tell me these two numbers here. Present worth factor and capital recovery factor, work them out. And then we have expected. Let's do it on annual basis. Expected annual damage from design A. Expected annual damage cost from design A. we have each time the damage occurs, okay, each time the overflow occurs, it is 625,000? 600,000.
Project A, 500,000.
No, the
Each time is 600,000.
600,000. So we have 600,000 multiplied by, remember that there is 0.15 chance of overflow occurring for design A. So 0.15, that is the expected annual damage cost from design A. And same way we can have expected annual damage cost from design B. 600,000 multiplied by 0.05. I think this is $90,000. This one is 30,000. And the expected annual damage cost, this is cost. This look like some cost from design C. 600,000 multiplied by 0.01. So this is $10,000. No, 6,000. 6,000. Design A is costing us how much? 500,000?
Yes.
So 500,000 annual design cost, annual cost of design A, annual capital cost or construction cost, annual construction cost of design A is equal to 500,000 multiplied by capital recovery factor. Okay, please tell me what is that? What is, how much you have calculated capital recovery factor? 0.102. And this is inverse of that? 0.97. 9.78? 0.979? Oh, sorry. Yeah, it should be 9.779. Okay, thank you very much. Yeah, you get confused, you know. All right. So annual construction cost is, when you multiply with capital recovery factor, what you get is 51 something or 49 or something? 50? Because it is multiplied with 0.102. 500,000 multiplied by 0.102, 5100, okay? Is it? And then annual construction cost of design B is, I think it was 625,000. Multiplied by capital recovery factor, what is it? Just multiply this 0.102 with 625,000. Huh? 63875. This is your design B, and annual construction cost for design C is equal to, I think this was how much costing? 900,000. So 900,000 multiplied by CRF. Please, this is also 91987. 80? Okay. Then we have the total cost of